Okay, we're going to look today at solving quadratic equations by graphing. Most of what we're going to do today we're going to use technology, although as we're going to do it, you're going to see most of what we're going to do today you could do by hand. First off, solving 3x squared equals 27. Let's solve that algebraically because we know how to do that, because that's in the form of ax squared plus bx, whoops, no bx on this one, x squared plus c equals 0. That's all the quadratics we did. I think most of you might be confused and say, well, geez, we usually did like ax squared equals c, where we had numbers. Well, that's what this case is. I just divide both sides by 3. X squared equals 9. Square root both sides. X equals plus or minus 3. And we're done with that question. Now, when we solve quadratics by graphing, what we're going to do is the only couple that you're going to notice is very similar to when we solved linear equations by graphing. The only difference is how many answers should we going to get? We should get 2 answers. That is, I'm going to rewrite the equation in the form ax squared plus bx plus c equals 0. That is, what I'm really saying is get one side equal to 0. Second thing, step 2, is we're going to write the related function. Remember, the related function is when you just replace 0 with y. So it's going to look like y equals ax squared plus bx plus c. Step 3, graph, either with technology or by hand, the quadratic. And find the x-intercepts. Remember, the x-intercepts are your solutions. So let's do a problem like that. In fact, we're going to do this same problem, but I have to import some graphs on here, so I'm going to pause you for a second so we get the graph paper on here, so it looks like it is on your paper. Okay, we're back and the graphs are there now. And so if we take a look here, step 1, make one side equal to 0. So what I'm going to do is I'm going to subtract 27 from both sides. And then I'll get a quadratic equation that's equal to 0. So I'll get 3x squared minus 27 equals to 0. Write the related function. So y equals 3x squared minus 27. Now I'm going to graph this. Now, I don't care if you solve it by hand or you solve it if you graph it by hand, if you graph it using technology, you still got to know what the vertex is so you can set your graph up so you can see it. And so we still have to find the vertex algebraically. So A in this case would be 3, B in this case would be 0, C in this case would be negative 27. And so when I'm going to make my table here, first let's find x, or the x coordinate of my vertex. So negative b over 2a, well, geez, does it matter because b is 0 over 2 times 3, so x is 0. So my vertex has the coordinate 0, negative 27. So that means if I'm going to solve this by graphing, I better set my window up so I can see it. So my graph better go down to at least negative 27. And notice, kind of running out of room here, but I still want to make my table. So let's put the table over here. So x and y, because whenever I make a graph, I want to have some table to represent equation, table, graph every single time. So 0 is at negative 27. Then I'll back up a couple, and I'll go ahead. a couple steps there. Then I'll substitute those numbers in. Substitute -2 in for x and solve that equation. Now, the nice thing about having a graphing calculator is we can do that right away. So y equals 3x squared minus 27. And then I'm going to suggest you, when you set up your table, put the independent variable to ask. That way we can put in whatever we want. So I go second table, and let's go -2. When x is -2, y is -15. When x is -1, I need to show up. When x is -1, y is -24. And then since this is perfectly symmetrical around 0, which I have a whole number, I know 1 is at -24 and 2 is at -15. So I'm going to plot those points. So now, if you're going to graph this by hand, make sure you tell me what the scale is. I'm going to have my x's stand for 1. My y's, I'm going to go by 3s. So -2, -15. There's -3, -6, -9, -12, -15. And then -1, I'm at -24, so it's 15, 18, 21, 24. As we'll plot both of these since they're there. And then -27. Now, if I'm going to graph this by using technology, the only thing I got to make sure of is in my window, I'll have my x be from -10 to 10. I want my y to go from -30 to 30, and I'm going to count by 5s here because that makes the most sense. I can see it that way. So if I graph that, if you want to graph that on your calculator first or second, it doesn't matter. Notice I can see here that x crosses at -3 and +3. So when I graph this, if I make it correctly, it's kind of V-shaped. It should be more of a gentle U. So -3 and 3 is my answers. What the heck happened there? I don't like that. Duh. I don't know why that showed up, but I'm not going to get rid of it because that's what we have to do. Now, let's take a look at the next one. I want to solve this one graphically, and I want to check my answers algebraically when I'm done. So I'm going to set up the same way, even if I'm going to use technology, or if I'm going to do it by hand. Notice it's in standard form already. A is 1, B is 1, and C is -6. So x equals -b over 2a. So I get -1 over 2 times 1, which will be -1/2. And then use my table. Here, I'm going to make it a vertical line. So when x is -1/2, let's find what y is. And we'll just do it on the calculator so you can see it. So my equation was, what was my equation here? My equation was x squared plus x minus 6. So x squared plus x minus 6. And since I've got it on ask, I'll type in -0.5 there. And when x is -1/2, y is -6 1/4. Then I'll just back up a couple, so -1 and -2. Here's 0 and 1, and I'll find each one of those. So let's start with x is -2. When x is -2, y is -4. When x is -1, y is negative 6. When x is 0, well, that's the same distance from negative a half to 1, so that'd be negative 1, or negative 6, and negative 4 again. So let's go and plot these points now so we can see them. So I'm to the left 2, I'm down 4. Now notice this one works out real nice if you're going to do this technology. We'll show you how to set this up here. So negative 2, negative 4, negative 1, I'm down 6, 0, or negative 1/2, I'm sorry, I'm down 6 1/4, and then 0, and then positive 1. So you can see that. Now if I want to graph this on my calculator, just go zoom 6, because we're going back to my standard window. And we can see there when x is negative 3, y is positive 2. So x equals negative 3 or 2. These turn out to be real nice. Now the question though, it says it's check it algebraically. So this one I want to see you work on. So put in 3 for x. So 3 squared plus 3 minus 6. So that's 9. Oh, it's a negative 3. So 9 plus a negative 3 minus 6. And notice I get 0, exactly what it's supposed to equal. And then let's put in positive 2. 2 squared plus 2 minus 6 equals 0. So that's 4 plus 2 minus 6, 0. So that checks algebraically. And that's all you have to do in that one. Okay, now on the next one, we got this word problem here. And notice we got some very ugly equations, because in real life equations are not necessarily done with integers. So we're going to probably use my graphing calculator here again, and I'm going to graph these. Definitely not going to graph these by hand. They're going to be too ugly. And I want to say, let's take a look at the first problem. It says a baseball is thrown at 100 feet per second from left field towards home plate. The model gives the paths of the ball for 2 initial angles with the height y and the horizontal distance x in feet. Now in this one, it says if home plate is 236 feet away, which angle have the ball hitting the ground before reaching the plate? Now notice what happened here is they didn't pick a good angle to throw out, did they? They kind of threw a line drive trying to throw it more horizontal. And of course, if they throw it too high, the ball won't get to the home plate. And if they don't throw it high with enough angle, the ball won't get to the home plate. So we got these two where the baseball player picks it up and throws it at some small angles here, trying to throw a line drive to the catcher to get the runner out. But if I'm going to graph this, no matter what, if I'm going to use technology or not, I still got to find the vertex of my graph so I can see what it looks like, and so I know what to set my window to look. So x equals negative b over 2a. I'm going to do that for each one. I'm going to start with the first one. So in the first one, remember a, b, and c. So negative 0.268 divided by 2 times negative 0.00171. So I'm going to go ahead and let's find that answer on your calculator. So I'm going to say negative 0.268 divided by 2 times negative 0.00171. And so this is about 79, we'll say. And now let's do the second equation. So x equals negative b over 2a. Let me change colors here so they don't get too mixed around. So I'll say negative 0.466 over 2 times negative 0.00195. So I'll take 0.466 divided by 2 times 0.00195. Notice I didn't say negative because I noticed the negative divided by a negative is a positive. And so this one's going to reach its height at about 119 feet. So in other words, of course, that makes sense. The second one gets thrown higher, so it should take longer to reach its height. Now, to find these equations, or to find these vertexes, let's substitute those numbers in. Well, I'm probably going to use my calculator on this one because this works out kind of nice. And let me see if I can see the equation here as we type it in. So negative 0.00171 x squared plus, what was it, 0.268x plus 6. Okay, then let's type in the second equation at the same time. So negative 0.00195x squared plus 0.466x plus 6. Okay, so we want to look at, now I'll hit second, well, let's press enter first, just to make sure. Now I'll hit second table, so I can look at it, and I said 79 in the first equation, so it's about 59 feet is when the first equation reaches its height. About 59 feet for that one. And let's do 119 for the second one, so you can see what that looks like. Now I'm looking at the second equation because I know I typed the equation for the second one in Y2. On you. And so that reaches the height at 84 feet. Now, the question, though, isn't find the vertex. The question is, hey, which one's going to hit the ground before it goes 236 feet? So now I'm going to do is I'm going to go to my graph, but this is where the graph comes in handy. Notice the maximum height I got was 85 feet. So here's what I'm going to do. I'm going to use my graph. I already got my equations typed in, so I just need to adjust my window. So negative 10 seems a good part. Let's go up to 250 feet since 236 is what I'm looking for. Or if you want to, we can change that. Let's just keep it at 236. See if which one hits before that one. Okay, and then if I'm going to go from negative 10 to 236, I'm going to have a tick mark, let's go over 20. Okay, now my Y max, remember, was, we said the Y max was at 84 feet, so I'll go up to 100. So I'm going to go from negative 10 to 100. And if I'm going to go have a tick mark every 10 feet or so. And let's graph that to see what it looks like. Okay, now, the question is, which line is which? Well, we know this one here, the arrow, that's the second equation, because that's, notice this is still going up in the air. Here it is, 236 feet is right here. Looks like this one's going to hit just below 236. Now, if you want to see the whole graph, let's make sure I type that equation in right. Negative 0.00195x squared plus 0.466x plus 6. Negative, there's my problem. I just noticed that. Get an extra 0 in there. And I sure hope my table was right then, dang it. Let's go back to our table. I made a mistake. Second table. So the first one was at 49. The second one was at 33. So they didn't go up that far. That's one of the problems with all these decimals. You get all these ugly numbers in there. So that means my window probably only needed to go up to 50. That's still not graphing the way my intercept says it should be. Let's make sure I type those in here again. Negative 0.00171 x squared. Man, I really messed up on this one. I got the wrong equation in there. Plus 0.268. So we'll try to take a look at that again. So don't make my mistake. Always double check before you do any calculations. But the nice thing about the table is as we change them, it just changes. So notice the first one only goes up to 16.5. The second one only goes up to 33. So let's change my window once again to 35 for the maximum so you can see it. Now let's take a look at the graph. The graph looks a lot much easier to see this time. Remember, the end of my graph is 236 feet. So the second one is still in the air at home plate. The first one doesn't even get to home plate, doesn't it? The first one does not get to home plate. So all that work for which angle, how the ball hitting the ground before it reaches the home plate, the 15-degree angle will hit the ground before home plate. And I think when we did this one in class, it worked out much nicer because we didn't have these mistakes.